first session is, as I said, ESG in refining. We have two speakers. I will have the first speaker, Mr. Ankur Goyal, President Works MMTC, to start his presentation first. As I invite him, a few words about Mr. Ankur Goyal. He's a seasoned expert with 29 years of extensive experience in precious metals industry. Mr. Ankur Goyal brings with him 18 years of specialized knowledge in gold and silver jewelry and manufacturing, utilizing the lost wax investment casting method. In addition, Ankur Goyal has spent 11 years mastering gold and silver refining as well as minted coin production. With a profound understanding of gold and silver metallurgy, master alloys, refining processes from mine to ray, Mr. Ankur Goyal is recognized for his expertise and dedication to the field. His deep knowledge and industry experience make him a leading authority in the precious metal industry. Please join us in welcoming Mr. Ankur Goyal to make his first presentation for the conference on the ESG in precious metals refining. Over to you, sir.
Thank you, Srivastava. And before I start the presentation, a few words. In fact, I would like to thank one of my earlier managing director, Mr. Rajesh Khosla, who was, I think, instrumental in getting the seed of this idea. And we did the first technical conference. It was a small 3-hour conference in one of the IBJA around 4 to 5 years back. And that was the seed which we thought, let's have a separate technical conference in India also. And simultaneously, another thanks to LBMA for they do every alternate years the technical conference, which is really brings the whole industry of the world together. India has been lacking in that because many of our refiners do not go to that technical conference because it becomes highly technical in terms of video, but it's a very, very enriching experience. And I see a few people from here. I think Mr. James visits the technical conference which is there, but it's very enriching to understand where the world is going. And today, that's why we try to collate a few of the speakers here, and as we go along in number of years to come, we might add further knowledge. And I think I was talking to few people. There's a lot of innovation which is being done in the space, which can be a good thing for future. Like I would say, I was talking to a person from ECOI, and they're doing a lot of developments in that space for the technology improvement. Okay, so that was the initial. That was because of this conference has taken shape, thanks to you all. Before I go into ESG, how many of you know about ESG? What is ESG? Environment. What does it cover? Sustainability. Okay. So I was talking to Srivastava, and he did have some queries when we launched this topic of ESG. He did have queries from people. Oh, we are doing CSR. We are doing 50 lakhs of this thing for the people. Is that ESG? Is that sustainability? So here what my presentation will be, it will be very basic. I'm not going very deep into the technical parts of how one can get how one moves into the ESG portfolio. But as we go along, because India per se is really going into sustainability, and even our Prime Minister, and I see a lot of big companies, I'm not talking of the precious metal industry, have gone for the ESG certification. And I would say from the precious metal refinery, MMTC PAMP has taken that first step almost 2 years back, and now we are into, I will show you what we have done so that you can get a basic idea as to what can be the roadmap for ESG. So I'll be covering what is MMTC PAMP. Many of you know about it, but I'll give you a small brief. And then what does ESG entail? And then the subsets of ESG, which is environment, social, and governance. So if you see, MMTC PAMP is one of the most trusted precious metal refinery in the ecosystem. We are into two main products. One is refining, and other is making coins. These are the various portfolios we have. We supply to a lot of retailers, jewelers, And we are the only LBMA accredited gold and silver refinery in India. There are few more LBMA accredited refineries which are into silver, but not in gold. We are associated also with government, which is the Indian government mint. We also are into the MTT committee. We are very close with NABL. I'm an assessor. I have another, my laboratory head is also an assessor in NABL. So we do discuss a lot with government how we can really go ahead with this sustainability part of the thing. So what is ESG? This is a small breakup of what does ESG cover. What is environment? What are covered in environment? What is covered in social? What is covered in governance? So how responsible we are in all these three fields, and if we can work out a few things in this, I think we are in the roadmap of ESG for the country. And as and when more people or more refineries, more manufacturing industries come over, we can be going into this roadmap. Like environment, definitely you see a lot of things like climate change, Paris Agreement is there. What is the ecological impact? The third point is the energy management. What is energy management? It means how much carbon dioxide you are emitting into the atmosphere. How can you control that? The greenhouse emissions, the risks, policy and regulation, and raw material sourcing, how much we are going for renewable energy and we are not using the grid which is there. Even the products, if you see, we have also embarked on the journey, and we are new, I would just say, on the plastic waste manufacturing. Whatever plastic waste, and we do have plastic waste, which is we give in terms of our coins, insert cards, and a lot of you as manufacturer use plastic. How do you set that off? Right now, government has gone and is in consultation with big companies like ABB and Schneider and all, who have got into plastic waste, that is called as the EPR management, but slowly they will come to the smaller industries also. Lastly is water and waste management. So that is entitled coming under the environment. Under the social, definitely here comes the CSR. So you see, CSR is a small aspect, and which I've written in the last, giving back to the communities. So that is a small subset of the whole ESG program. What do we do with community relation? Inside your company, how much diversity, equity, and inclusions you have? How much is the employee health and safety one company is looking up? What we are developing for human capital, labor management? How is our data secured, which is there? The product quality and safety, supply chain standards, and finally, what we give back to the society. Coming under governance, and that's the most important point, which now even the Indian government is very keen, is anti-bribery, anti-corruption, business ethics, corporate resilience, diversity of leadership, executive compensation, owner structure, and tax transparency. So here, what I would say for us refiners, the most important thing is how we can source responsible gold. That is the most important from the mines, from any of the recyclers. It should be as responsible. And you must have heard of whoever are supplying to the jewelry world now, there's a word called ethical gold or green gold, which is not the mined gold, which is coming from the recycled gold. So that is also a lot of companies like Walmart, JCPenney and all are asking, like Pandora is trying to only take recycled silver and gold, silver, which is happening, and they have a huge consumption. So this is what the whole gamut of ESG corresponds to. So MMTC PAMP definitely has, with their initiative in this ESG framework, has put India on the global map of precious metal. And now we can really vouch for that. As a refiner, we are working for this. And what is our goal? So first, if I go to the environment, this is our goal. So we are the first precious metal company in India to secure the science-based carbon reduction targets approved from the prestigious science SBTi. What we want to do is 47% reduction in scope 1 and scope 2 greenhouse emissions by 2930. benchmarked against 1819 baseline of 7,900 tons of carbon dioxide. So what does scope 1 and scope 2 entail? Scope 1 and scope 2. Scope 1 entails is whatever emissions we are making using our DG sets, using our boilers, using our furnaces. Those emissions are calculated and we calculate how much is the carbon dioxide, this thing. Scope 2 entails is how much grid power we use. And it is not the grid power we use only in our factory, in our offices, in our households, which is the grid power. And all that is calculated, which comes into our gamut of MMTC PAMP family, which is there. And there we are trying to work out a 47% reduction. And second is the reduction in absolute scope 3 GHG greenhouse emissions by 27%, which is by year 2930 from our benchmark of 1819. So we calculate every year how much is the carbon dioxide emission is there. And this is a staggering figure for a refinery. And I'll explain why it is almost 3.9 million tons. So here scope 3 emissions comes from the outside sources. It comes from what is the emission which is done by the mine, which from where we are taking the gold, doré or the unrefined gold, or from the recycler from where we are taking. All the transport of that material from the mine to our this thing, coming through road, coming through flights, what is the carbon dioxide emission we are this thing. So what is the work which the mine is doing? Here I can say I can reduce straight 27% in one go by not taking material from that mine which is having a higher CO2 emission, but I can't do that. So we are working out with the mines what are the various things which they are doing to reduce the this thing. And based on this, what is our goal? Our goal is, I'll just show you, our goal has set up a science-based target consistent with limiting climate warming to 1.5 degrees centigrade by 2930. That is our goal. Today, the warming is up to around 1.1 degree. We want to reduce it to, we want to limit it to 1.5 degrees centigrade. So that is our goal which is there. And our first road installation was installation of almost 705 kilowatt of solar panel all over our terrace, our parking areas in the factory, which could reduce around 570 tons of carbon dioxide reduction, followed by various other initiatives. I'll quickly show all the other initiatives where it is a reduction of another 500 tons. This is there. So this is, I'm not going very deep because this is a bit deep into this thing. But these are the science-based targets. So SBTi is an organization which mobilizes industries across the globe to act towards climate change through various initiatives. So we submit the targets that we are going to work on these targets. Once they approve their targets and then we start monitoring it, we start working it out and they monitor it and help us to go ahead with this thing. So that's our target of 1.5 degrees centigrade, which is there. And this is a certification which we have got from SBTi to have our trajectory to 1.5 degrees centigrade by 2930. So this is the solar point installation which we have done. You can see the whole terrace. We have a huge, we have two factories at Rochkamio, Nu, where we have installed full solar panels on the whole thing. These are the second picture shows all our car parking area which is having the solar panels which are there. So, and these are the various initiatives which we have done in terms of, if you see in the terms of governance, how do you reduce water consumptions? How do you recycle water? And how do you reduce your LG? The whole factory has been changed into LED lighting. We have done various machines projects. I'm not going into the technical details of wherever we can save energy going out. In case of recycling, how we can use the water, recycle the water. Like the DM water once used, the waste can be used as a RO water which is there. Revamping of our ETP, STP, this thing, so that whatever water which is coming out from effluent treatment and sewage treatment, we can reuse in the factory. and we can use it for irrigation. We have put a number of, I would say, UV sensors, RO units after the treatment so that the water come out is as pure. I know we cannot drink, we do not want to give it for drinking, but we can reuse it for our other operations, which is there. So that was what is governance, and it's a fairly large subject in terms of energy control, energy conservation, and I've just highlighted few of the points. If I go to the social aspect of the thing, definitely, if you see in my small slide, the first important thing which comes is how you are taking care of health and safety in your plant, in your working atmosphere. Are you doing your medical checkups? Are you giving them a proper PPE? Whether, and refineries, as many of you know, is having a lot of fumes coming out. So what are the scrubbers which you have installed? In fact, I would like to state that our total capex investment in MMTC PAMP, 25% is on the ecology setup, where we control all the gas emissions which is coming out from our various banks and all, and regular safety training workshop. So this is what we do inside, and there are many more things. I have not listed on everything, but going ahead, and now comes the social aspect of what MMTC PAMP is doing, and I'm sure many of you would be also under your CSR would be doing, where we are doing education empowerment, health and nutrition. Per se, I would say the area where we live in is a Rochka Mu, and you must have heard of that area in the last year also. There was some rioting and all. It's a new area which is very underdeveloped. So we take care of few of the villages there. We provide them sustainable energy, clean water access. And this is what is our roadmap for this particular area, and these are the areas where we work it out. And like we have provided new RO systems to almost 12 schools covering almost 8,000, 6,000 to 8,000 children, which get pure good drinking water, healthcare, nutrition to the village area. And some of the schools we have fully revamped. I'll show you a few of the pictures where we have fully revamped this thing. This is transforming the whole infrastructure, which is this school. If you see the whole infrastructure, I'm showing the small this thing. If earlier, if you had gone there, it was totally black. No lights, nothing, and there was kids studying. Some of the small villages are really in a bit of a bad condition. So we revamped the whole education, the whole school for the girls. We also did support the villagers in terms of healthcare and nutrition, regular medical checkups for the housewives of the villagers. We did solar installations, and this was the school which we again a part of and solar installations, so that they can get lights, and this is the way the whole infrastructure was developed. And the RO drinking water, which I can work it out, which I just said about that. So this was on social, and social does cover a lot of gamut. We keep on doing it. Definitely, it is also we can have it is also a push from the government. You have to invest something like 2% of your total profits, average of 3 years profit, to the society. And in fact, here I would like to point out our main group, which is MKS PAM group, has invested another % of their profit for this CSR activity in this region, which is there. Coming to governance, I'm not going deep into it. In a small way, I would just say, if you see governance, we do follow a very sound, we are LBMA accredited refinery, where we do have a full yearly check for responsible gold. All the gold which is coming from mines are after proper KYC, proper check, proper visit to the mines. We also have the Responsible Jewelry Council certification for code of practice and chain of custody, where we do produce in gold. We have for gold, recycled gold, which we give it to the industry whenever they ask for. And we have other means of having an ethical standard in terms of SA 8000, where it covers the social accountability, covers no child labors. So, and other accreditations, I would say. So, this is what I would say is covers the ESG framework. I'm not saying this is what it is. There are almost 17 SDG governance principles which one has to follow, and if I show you the other slide of SBTI targets, huge, and the calculation is not very simple. In fact, the third aspect also covers how you travel, whether all our employees are using electric cars or not. So that is the way the industry is going forward. Our parent company has developed, has gone more deeper into the ESG targets to set off carbon dioxide emission. So yeah, thank you. This is a small this thing. Any questions?
Scope 1, Scope 2 reduction is the initiative what you take, maybe solar. So it will have an impact on your PNL.
Definitely, yes.
Scope 3 doesn't have.
Scope 3 will also have. Scope 3 will not have much, but scope 3 will, no, it will also have. I'll explain in a small way, not in our case, but in many other cases. See, scope 1 covers what are the emissions you are doing for DG. Now, if you say in India, right now, I'm paying almost 33 rupees per unit for DG whenever the power goes off for an hour. 33 rupees per unit. And while normal electricity is 8 rupees. So if I put a solar, where again I'm saving another 2 rupees from the normal electricity. So there is a huge saving the moment I go for solar this thing. There's another thing which is biomass. If I add biomass into our system, I'll be reducing LPG consumption and also those are the things which scope 1 can save. Scope 3 is important, is it also covers, I would say, use of electrical vehicles. So there we can save on employee. If a company can provide electric vehicles, they can save on the diesel cost. And that's a very small sector. There are many other things which are there.
One important aspect about your refinery industry is disposal of refinery waste. So
Yes.
what your company has done for this refinery waste is a most important part of ESG, I suppose.
Yeah, so that is true. What we have done is we have our in-house setup for working out the disposal of the waste. And I would say, if you see what are the waste which are there, one is water. Whatever solution, whatever the effluent treatment plant you generate, whatever solution you have to dispose of. So what we have done and is what we have set up. We have crystallizer and concentrate, which operates all the water and converts it into salt, which we dispose out to a proper recycler. So that is where I close the water loop which is there. Simultaneously, if I ask for the other waste, for the moment you see you get one water, and other thing you can get is the sludge. Once you do the refining, this thing, a lot of copper goes into the sludge, and then you have the copper which may have gold, which is there. So that is something. There are recyclers all over in India. I don't see much, but there are recyclers abroad. And what we have done is we have set up our own low-grade recycling furnace. It's a huge furnace of 2,000 ton waste, which can treat all this copper hydroxide sludge and convert it into billet, which is there. Plus other waste which are there is like your crucibles, your slags which you are generating, which does contain precious metals. So that all we have set up the top blown rotary furnace which is there, which we have set up, takes care of that. We didn't have this 5 years earlier for our slags and crucibles. Now we have that setup which we can use it. So I can recommend, it's not, I'm not saying it's not anything like a rocket science. It's just an equipment. People can buy it, can install it and process it, because every refinery, what I have seen, I've been I've been heading this refinery for almost 15 years. There's a huge amount of gold and silver which is going out in the waste, which one can control.
Hello. Hi. Thank you. Mahesh from Marex Financial.
Yeah.
Thank you for the initiative. It's a really nice initiative. Thank you. My question is on the ESG aspect. In your discussions with the government and any exchanges, have you talked about carbon trading as well? where you can offset your save on the ESG
So
aspect?
currently, Indian government earlier it had, but right now there's no carbon trading which is there in India. It is there in Europe. You can trade the carbon credits and you can offset that which is there. But in India, we don't see it. So our offset is mainly by whatever I have explained in terms of energy saving, water, and whatever we are saving right now. But I think if Indian government, I'm not very much deep into it, but if Indian government starts the carbon trading, it can be on a positive side. In fact, there is a lot of renewal parks which are there. I know it is in Maharashtra and all, but we are in Haryana. Haryana government has not even until now given the license for renewal parks, because that is one of the things which once can come in, can really save a lot of grid power which is there. See, what we are working is only 8,000 tons. When we calculated, there's a 3.9 million tons of, and that's major chunk is because of the doré which we import, and it comes from flight and all those things. So if we can really work that out, unfortunately, India is not having mines. We have only one Hatti gold mines. Otherwise, that carbon footprint can also come down. But if we can work out something with the mines, we are if they can work out some of the control which is there, it can benefit us from, because now the mines are also aware of this. We have some calculations of how we calculated 3.9 million tons is not, we have calculations from whatever mines we are importing, what is their carbon dioxide emission. Based on that we calculated, and then we are working out how they can control and how we can also what you can say, make it economical for us to import into India, because it's all coming through flight. So that is another area which is being worked out.
So indirectly, you're saying moving to entirely recycled gold.
That's the world. That's what I would say.
Recycling as an activity, like as a major source.
Because there's a huge amount of gold in the country. I would say country has 25,000 tons. And we buy almost 700, 800 tons. So that 25,000 ton can always come from inside our own resource rather than getting mined doré which is there.
This is coming from the largest refinery which has got the most extensive CPTCs in the country.
Yeah. So, and I'll tell you, when we started off way back in 2014 for recycled gold from the Indian market, I won't say what we are now, but we were just getting 500 kgs a year in 2000. And today we have grown like huge. It is really going way beyond what we expect of from our 14 centers in India. It's huge. And that's why I would say whatever we are getting is only a small chunk, though it's very big for us. But it's only a small chunk with the 25,000 tons which is there in India.
Another question for smaller refiners, like, can you justify this cost at your scale? It's okay. For smaller refiners, many of whom are here.
I think it is possible, because refining cost, it only what I would say, it is only the mindset where you set up a standard. And for small refiners, what I can say is, in order to get a business, or in order to get what they call it is the percentage, or in Indian terms they call it tunch, which is there, that keeps reducing, and that's where the competition is. So if all the refiners set up is we would charge so much, say 0.2%, 0.3%. Today it goes to, okay, I'll give you the refinery in 0.1% or 0.05%, and that's where everything changes. And with that change, you will be tampering on the purity, you will be tampering on your process, you will not be investing on the right kind of machinery. Like today, I would just, since he has asked me, I'm into also building up the standard along with Mr. James, Mr. Kansara, for the hallmarking of bullion. That standard is slowly, and hallmarking of bullion is slowly going to come into India, and government is very keen. What we see is there are three sets of people. One is the refiners, the BIS accredited refiners. One is the imported thing, and the third is the unorganized sector. And unorganized sector still does refining using the nitric acid method. So now they are promising us that we are now going to shift to Aqua Regia refining, which can help them to get accredited and come into this. So So my suggestion is there's a huge amount of gold in the Indian market. We should really capture that.
There's a question for Mr. Hiriman. Are your industry covered under ISO 14,000, ISO 50,000?
Yeah. Ours is covered. Ours is covered fully. We are having ISO 9001, 14,001, 45,001, and 3 years back we also went into the energy management 50,001.
Any more questions?
You mentioned about this ESG certifications. Like, is there any governance body right now who certify saying that your particular plant is ESG compliant?
No, there is no body. What we have to do is once see what are the steps. First step is you calculate what is your mission. What is your scope 1, scope 2, scope 3. So there are agencies, I would say ENY helped us. There are agencies which help us to calculate. Once you calculate, there are agencies, same agencies can tell you what are the various areas where you can reduce. Like for another thing, we are using a lot of LPG. So there is a thing that you can use biomass. And then there is this body which I just told you, the SPTI body. It's an independent non-profit body where you have to submit your targets, that this is what I would be working out. And then they monitor it. And once they approve you, you can always state to the world that this is what it is. But there is a regular monitoring where you monitor and publish it, that as per the if ENY certifies us that this is the thing, that can be worked out.
Just to add, for the SEBI, Securities Exchange Board of India, the top 1,000 companies, ESG reporting is mandatory from this year. It was voluntary till last year.
There is a total BRSR reporting which is there.
Top 1,000 companies that turnover listed on the stock exchange.
But then this reporting, that's what I was asking about. Who regulates this reports? Like, suppose we mentioned about UI, is there any body who checks on periodic basis whether they comply or not?
I'm not aware of that, but I can check it out.
Is it a part of the LBMA report?
No.
Right,
Thank you.
To do us the presentation, the recovery of precious metals from e-waste, recent updates. We have Professor Deepoo Kumar, Assistant Professor from Indian Institute of Technology, Mumbai. Before I invite him to make a presentation, a brief introduction about Professor Deepoo Kumar. He is a BTech and MTech from IIT Mumbai. In 2013, he completed his MTech. Thereafter, he went to Carnegie Mellon to do his MS, and then subsequently PhD he completed in 2018. He has had industry experience both in L&T and Praxair. His specialization includes steel making, additive manufacturing, and recently metals recycling and recovery. We are very fortunate to have him here. He's taken keen interest in metals recycling and recovery, and he's not from the industry, and I'm sure that we are going to hear a lot of new things from him. With this introduction, please welcome Professor Deepoo Kumar to give his presentation.
Thank you. First of all, as it was mentioned in the introduction, I'm sort of outsider here, right? Or maybe recent joinee or whatever. So, being from academia, you will see the talk will have more research bent, and please feel free to ask questions and clarifications, and also if you have any suggestions, because you guys are stalwarts in this field. So I have taken the interest in this. Fundamentally, I'm a process metallurgist working on the extraction and refining of metals, primarily in steel. But in last 3-4 years, I've been working also on the recycling of electronic waste using some of the concepts that I learned during my PhD and so on. Just to give you a bit of background, and I will not spend a lot of time here, but I primarily have work on 3 verticals in the research. I have many experimental setups, all are high temperature. We are talking about ESG in steel actually contributes to about 7 to 8% of global CO2 emissions. So that is a huge issue for steel industry. So we are actively working on the ways to reduce that emissions there. One of the ways to use hydrogen for the reduction there. And we have many facilities. We have environment control induction furnace. Some of the results that I'll show today are from that facility. We work on the melting and refining of metals, steel, aluminum, and copper. Today I'm going to talk about e-waste processing part, and then there's some more details. More recently, I'm also getting involved in the developing of metal matrix composites for the mill liners that is used in processing minerals. I also do process modeling using fundamentals of thermodynamics and kinetics, primarily using factors. It was nice to chat a little bit with Chris there about this. Then we are extending this model to using what chemical engineers a lot is called Aspen Plus. So integrating these fundamental models to large scale models so that we can simulate the entire plant and do the optimizations or do the studies if we want to change or from one reactor to next reactor, what is going to be the effect on the production as well as cost. I also do quite a bit of characterization, and some of the unique facilities that's there in the lab include this high temperature confocal laser scanning microscope, where you can do have microscopic observations at very high temperature up to 1700 degrees Celsius. So you can look at all the meltings and refine or even the reactions between melt and slag and things like that live, and how does the reaction actually take place. I also work on, there is a microscopy technique called scanning electron microscope, which traditionally we have been using to take some images, but we are working on the automation of that so that we can generate large amount of data that can feed to now being popular, the AI and ML type models. So the single objective here for this work has been that we would like to develop a process to recover metallics, including precious metal from waste PCB using high temperature processes. Of course, there are industrially developed processes. I will not talk much about that, but here the main goal is to do something at the lab scale and see if we can come up with some innovative processes that specifically can be used by small players. This is what PCB looks like. It is present in all your laptops, in mobile phones, your screens, and so on and so forth. So if you take up this green color looking board, you have a lot of these things called components. You will have capacitors and IC chips and so on, which has totally different composition than what is embedded in that green board. One of the first tasks one should do is to remove these components, and we have some recipes to remove this from the soldering. You dissolve the soldering and then you can remove these components. Then it looks like this. This is now lot more concentrated, and these are again lab skills, so a lot of these things are done manually in the lab, but of course there are processes that can you can automate it. So what is the PCB is primarily, once we have stripped off these components, it is primarily 30% of resin, about 40% of fiberglass. We'll learn a lot more about this little later, and then 30% metal. In that 30% metal, primarily you can have copper, tin, iron, nickel, zinc, aluminum, mostly in that order. And then precious metal is silver and gold. Silver is typically 1000 ppm. In some of the, you will see later, we have observed 600, 700 ppm and so on. This is more detailed value, not from our work, but from a reference, which is a very nice paper written by some Australian researchers. This is the overall percentage of material present there. So if you look at gold, etc., it is in, depending on sources, it can vary 10 to hundreds of ppm. Similarly, in some sources there are palladium as well and silver. But if you look at, this is the important part which may attract some of your attentions. If you look at the cost wise, the values here, then you can see there are, let's say in mobile phone, although the amount is maybe in ppm level, but the cost wise that is about 93% of total value of that waste. So it is highly concentrated, and even if it is in small amount, overall cost value is quite a lot. This is, again, I said I will not go in detail, but this is what the large scale refineries look like. This is Umicore process. Sorry, I haven't included reference, but it is from one of the published articles where you start with main reactor, and then it goes through series of processes to finally have the precious metals out by these refineries. The aim here is to look at some alternate process which can work at relatively smaller scale. So these PCBs were procured from local shop, and as I said, we have a recipe which is based on methane sulfonic acid and hydrogen peroxide to dissolve the solder, and then you can shake it and remove the components so that you have component free printed circuit boards. We have this facility which is again we have been using this facility for a lot of refining research for steel. Here what we have essentially is a stainless steel chamber which is closed from any air ingress. We do experiments under argon atmosphere using different type of crucibles, but you can have your melting of PCB and or mix here in an appropriate crucible, and then we pass the off gas through water before discharging it out. Of course, it can be further improved by putting scrubbers, etc. This is how it looks like. So we designed it in-house. This you can also see from the viewport during the operation. It looks quite bright. Anyway, there are several set of experiments that have been performed. My goal is just to flash it, but I'm not going in detail about all of that. Only some selected experiments where we got very useful insight. I'm going to talk about that. The first one is, since we have this PCB, there is also a recipe to remove the resin from here, so you can further strip it and have a more like just fiberglass and the resin. So the structure is you have fiberglass, and then you have the printed electronics, and then that is with the resin. So you can strip the resin as well. So the first thought was that you can just melt some copper, drop this PCB, and then it should melt, metal should melt and go to your copper, and then you can process that copper later. So we had shredded PCB that was dropped in molten copper at 1300 Celsius. And the expectation was that metals in PCB will melt and get collected by molten copper. We tried with both, with epoxy and without epoxy, both types of experiments were done. However, after the experiment, we find this. So there is some discoloration of copper. Primarily, we found there is some lead that has gone the copper, but there is a lot of unmelted residue, and which looks like this. You can see this woven structure, which is essentially the fiberglass that is there. If you look in detail, these are microscopic images, very beautiful image, but showing that the copper has indeed melted, but could not be separated from the fiberglass because those are very small droplets, and it's a woven thing, so it it is not able to percolate through and go in the melt. You can see this is copper. There is a small gold peak here as well, but primarily it is copper and tin. And there's and of course there is some fiberglass, which is essentially SiO2, Al2O3. Okay, so this was again, so I presented it as one slide, but this was 1 year of work for one master's student. Then we started looking at this fiberglass in little more detail, what they are. So we bought just the FR4 sheets without any electronics. And then we roasted it at 800 Celsius so that we get rid of any plastic if it is there. We get this, which can now be crushed. So then we crush it, sample it, send it for chemical analysis. It comes out about 50% silica, about 13% calcium oxide, and 37.5% alumina. Then we have this software called FactSage, which has thermodynamic databases and can calculate how would it behave. This thing will behave if we start heating at high temperatures. So this is on y-axis is the fraction of liquid. So if you take 100 grams, how much liquid will be there as you heat it up. X-axis is temperature starting from 1300 to 1600. So up to 1360, there is no liquid. So you start getting liquid, but you have to go as high as about 1550 or so to get sufficient liquid. So that is very impractical if you want to process copper containing melt. You don't want to go to 1500, 1600 Celsius. So then the goal was, what can we mix to lower the temperature? If you look at literature, at least at research scale, people tried mixing boric acid and so on. But there are two concerns, at least one to start with is one is, of course, it should have enough liquid fraction at low temperature, at as low as 1100, 1200 Celsius. And it should have sufficient viscosity so that it allows the percolation of your metallics from this thing. Of course, one can go and do trial and error and keep mixing boric acid, calcium oxide, etc., and see what happens. But we use the fact size to do the calculation, design the flux, what we are going to make, and we did mass balance. And as you will see, we did not even need a second trial. In the first trial, you will see that we are able to melt it. Before that, I'll come back to that. However, we learned something more along the process. This is experiment where we did inert pyrolysis of WPCB, waste printed circuit board, where pyrolysis was performed under inert atmosphere in argon, but one can practically do in the nitrogen as well, only at 800 Celsius. Most of this recycling practices are done at least at 1200, 1300 Celsius, but here it is only at 800 Celsius. So once you roast it, you can see you get a mass like this, which is mixture of some metallics and some non-metallics like your fiberglass, which can be physically separated into these chips or foil-like species, and then you can press it. This is done for the shredded PCB. Similar exercise recently we have also done for the pulverized PCB, because some of the plants use the pulverized PCB, and you can also do the intermediate, heat it at 800 Celsius and then do the density separation, and you can separate the metallics from there as well. So then this was, after pressing, this was melted, and now what we have essentially is copper tin alloy. We have done microscopically there are copper rich regions, and then there are tin rich regions, and then there are those dark spots which are essentially sulfides. But then ICP analysis have been performed both AES and MS, and it shows about 84% copper, 11.5% tin, then there is some iron, 670 ppm of silver, and then about 30 ppm of gold. So this is, so please note that there is no high temperature process, I mean nothing like 1300. We have just physically separated after pyrolysis at 800 Celsius and then just remelted. In principle, this can be directly utilized for from other means. For example, if you are going to dissolution, etc., you can just directly do it from here. Now coming back to the problem of the flux design, where we actually designed the flux, we did all the calculations to design flux that can be mixed with the remaining amount. So please note that here we had removed, but then some of the black thing that you see, those will also have some metallics. So we want to do the further refining. In order to do that, we have to melt the fiberglass. So we did all the mass balance, we designed the proper flux, and then made pellets. So you can crush that, make to powder, and mix with the flux and make pellets. Then we have the copper, which we are using as collector, and then those pellets were placed over it. Then we processed it at 1200 Celsius only, and after the experiment, you don't have any solid fiberglass left. So you have slag, you have metal separated. So this is copper rich metal, and then this is slag, and you don't see any fiberglass. So this is the power of those calculations. We didn't have to do trial and error, that we do increase this or decrease that, and then do the trials and come up with what works, what not. We can do these are very robust software and can be used for such calculations. So again, some microscopy, but essentially what we have is again copper tin. In this case, since we have used copper collectors, so things get diluted. So you can see it shows only 1.56% tin. Since this was a small amount, so we had to use copper because the mass contained very small amount of metal, so it would have been difficult to separate. But in practice, if you have large volume, you don't need to use the copper collector. Things get diluted, so you have only now few ppm of gold, but there is we did not find any major difference if you do the mass balance, major difference in composition in either of the case, whether you had physically separated and then except for silver, where you can see that even after diluting 10 times, there is 120 ppm silver in this case compared to 700 ppm in the previous case. Okay. So this is what we have come up. So we have waste printed circuit board. You can pyrolyze at low temperature. There will be some gas evolution starting from 250 Celsius onwards. Then you have residue, which you can physically separate, and then you can melt, and then you have the copper tin alloy containing your precious metals as well. Remaining residue you can mix with the flux and remelt it at 1200 Celsius, and then you have your again separated. You have separated all the fiberglass things, and you have metallics there. Okay, but I don't know about the cost. So That is where your inputs are very much needed. But there are some groups who have shown interest in taking it up, so we'll see how that works out. So I would like to thank, of course, the work is done by students and postdoc. So Dr. Santosh, who is postdoc with me, and Sai Prakash is a PhD student who has recently started working with me. Then these two are master's students who have graduated. Laboratory staff who has helped in setting up these facilities and working on. Of course, funding sources. DST SERB funded the furnace for a separate project, and then there is internal funding for FAPSIS. But all of the project funding have been somehow arranged from other sources, but not yet supported by any recyclers. So I'm still looking for that part. With that, I would like to thank you. If you have any questions, you can ask now or contact later. And for the future, we have started also working on the tantalum recovery from the capacitors on the printed circuit board. So you can see at least a glimpse of that. We had, this is cryo-treated capacitors, which were crushed, and then we could separate, we have started separating tantalum, and there is also a good amount of silver in that. Okay. With that, thank you, and thank you for the nice opportunity to present. Yeah, so there are a couple of things here. One is if you conventionally, if you do it by using oxygen, as you know, then you actually create dioxins that are big problem. Here it's pyrolysis of resin primarily. There is some evaporation of mercury or mercury or lead or arsenic. That is a concern, but that can be condensed and separated hopefully. That part, it still needs some work on that. But we have been collecting the condensed, you know, when you have vapor formation at low temperature, we have been condensing it and collecting and looking at those things. So there is some mercury, etc., but it doesn't go in the gas phase because we condense it. We pass it through. In our case, it gets deposited on the chamber wall, but it also can be collected in water itself, and then you have to think how to treat the water. Okay, thanks. That was starting material. No, but WPCB, if you start in the metal that we get, copper has about 700 ppm of silver. ppm is, sorry, parts per million. So 700 ppm will be 0.07%. 700 grams per ton. Thank you. Yeah, 700 grams per ton. So gold, it's about 30 grams per ton. Yeah.
So recycling economics works on what we feel?
So recycling would work out, I would say, depends on how you do it. If you ask us, minimum you need to have at least 200 grams.
That is even at your
Yeah, because there is a cost. But if you go as to the downline setup, which is like the Moradabadi unorganized setup, you can have even 50, 60. So that's a bit of
Thank you, Prof, for the presentation. I think it brought some fun memories for me because I used to run a similar operation. For us, I think because we're using almost similar to the metallo process, our incoming was 100 grams per ton, so we could effectively recover. And then even to the last step that we mentioned, copper is a better recovery because of its ability in the end to strip out the gold into the hydrometallurgical circuit. So this is the good route.
Yeah, thank you.
different generations of.
Yes, it would, but I'm not sure if our, maybe Ankur, you can comment, but the collection process, you know, it will be very difficult to mark the grades of circuit board. You can probably go back and do at the source level, whether it's from laptop or computer, there you can have some characteristics, but generation wise it will be quite difficult to segregate. That will be my understanding.
They are able to segregate.
Generation wise you can do. Okay.
Recyclers who are segregating. First segregation is going as desktop, laptop, and the server boards. And second it goes as a generation wise also, Because if you see today, earlier it was what he said, 300 grams, 350 grams. Slowly it is reducing to something like 100, 150 grams. Even our mobile phones, if you get that digital mobile phones, the button ones, the old Nokia ones, that has higher gold than today what we have in our mobile.
The technology that you're talking about, the pyrolysis,
Pyrolysis.
to cater to the different circuit boards.
Yeah.
That's
That is technology independent.
What is the flux that you use in this? And the composition of the flux?
Yeah, it is typically what we have the slag in this kind of pyrometallurgy process. So it is calcium oxide, alumina, not alumina actually, because alumina is already quite high in the fiberglass. Calcium oxide, silica, FeO, and little bit of boric acid, or sorry, boron oxide. So there's, of course, you need to use the tool to do that calculation, also to do the mass balance properly, how much flux is needed in how much of PCB. It can be optimized for a given condition. What is your feed rate, etc. Based on that, it can be calculated. Yeah, that's where the cost part comes. So we need to see, as Ankur also said, that depending on the amount, his number was about 100 gram per ton. So this.
Economical level of gold which is there in the PCB, which makes it economical for you.
Oh no, that's the one for us. Correct, yes. But I had the question around the slag.
Yeah, so it is calcium oxide, silica, FeO, B2O3 based boron oxide. You need a little bit of boron oxide to reduce the melting point and get some fluidity as well.
Yeah, hello sir, I have questions about the sampling and etching of the metal that we are recovering after the melting. Actually, what we are facing when we are getting the metal recovered from the PCB, there is a issue of the inhomogeneity, because when we are getting it, there is a lot of the tin, iron at the upper surface. So if we are going to remelt it with the additions of additional copper, then it is diluting.
Yeah.
Then it is very typical to do the analysis and capturing it by ICP. And if we are not doing that, then is the inhomogeneity. So how you are sorting out this issue?
Okay. So one is that this heterogeneity that is there. But first, let me clarify the copper part. Copper I used as collector because I had very small mass. So I needed some collector, otherwise it will not separate from slag. But if you have larger volume, you don't need to use copper collector. Now, second part is sampling. In our cases, we sample from the liquid. So we have ways to take sample from the molten state itself, so that the homogeneity is preserved, so that we'll know how much of gold or whatever is the composition. So it's not very complicated, but we do that. At least at lab scale, it's not complicated. Okay.
Any more questions? What kind of support you require from the industry?
See, support, I have told what I have and what I can do. Now it depends on what kind of problems they have. I don't want to bring problems should come from that side, what is needed. Then I can tell, But what my point is that this industry is going to grow in India, and many companies are getting. So now from our side, we can offer that we have these facilities and expertise. So we can do the projects that is relevant to you. In addition, if the industry grows, you also require manpower. So all our graduates, let's say I have so far at least 2 master's students who has graduated, and few others have done seminars, etc. So those people are now aware of what kind of problems it is and how to study these things. That's what happens with large industries. Like you need continuous supply of manpower as well. So these two things are there. So the problem must come from industry when it's industrial project. If there are fundamental work that I know but fundamental work, I can ask government for funding. But industrial projects, the problem must come from the industry. We can talk and zero down what is the problem and what can we do.
Is the technology established now for various scale?
It is not scaled up yet, no. So we need to. Now I again need some people to work on it. Again, people who want to take it forward have to come, and then we can. Thank you so much.